it's Lucy, and today we're going to solve a geometry problem using the knowledge we learned in the past combined, and a little bit of extra knowledge as well. So let's get started. First, let's take a look at the question. The figure shows two congruent isosceles right-angled triangles, ABC and EFG, with FE and AC intersecting at point K and being perpendicular to each other. If AK and BH are 6 centimeters and 4 centimeters long respectively, what is the area of the shaded region in square centimeters? The main idea of this problem is to exchange the same areas when you can't find the area of one shape directly. For example, in this question, there are two congruent isosceles right-angled triangles and they are overlapping. When we cut the overlapped part out, it will leave two parts on one side and one on the other, which are equal to each other. It leaves us with two isosceles triangles on one side and an irregular polygon on the other. You will see that you can't find the area of the polygon directly, as the question asked. That means we have to exchange the two parts, as we know their areas are equal. So that means the area of triangle AKF plus the area of triangle FHB equals to the green area. We know for one thing that one side of the triangle AFK is 6. And since this is an isosceles right-angled triangle, we know that the base of this triangle is 6, and the same applies to the height, because angle FAK is 45 degrees, and angle AKF is a right angle. That means that angle AFK must be 45 degrees. And since the two angles are equal, this triangle is an isosceles triangle, which means that line FK and AK are of the same length. And then we need to divide 6 times 6 by 2, leaving us with the area of triangle AFK, which is 18 square centimeters. Now, let's move on to finding the area of triangle FHB. There are two ways to find it, as I said earlier in the video. We are gonna combine all that we have learned to solve this problem, by which I mean the Pythagorean theorem and the area formula of a rhombus. First, let's use the Pythagorean theorem. We know that the side opposite the right angle has a length of 4 cm. We can use the formula, which in our case is the square of FH plus the square of FB equals to the square of BH. We know that the square of 4 equals to 16. It means that the square of FB plus the square of FH equals to 16, as we know that triangle FHG is an isosceles triangle, because we know that angle KFH is 45 degrees, and angle AFK is also 45 degrees. That's why angle HFB is a right angle. That means that angle FHB and angle FBH are 45 degrees. And that's why FB equals to FH. We also know that 8 plus H equals to 16. That means the square of FB, which equals to the square of FH, equals to 8 square centimeters. So to get the area of the triangle, we have to divide 8 square centimeters by 2, which is 4 square centimeters. And as we calculated just now, the area of triangle AFK is 18 square centimeters, and the area of triangle FHB is 4 square centimeters. 18 plus 4 equals to 22 square centimeters, and that's the answer. So now we have the answer. Now, let's use another method. Let's duplicate this triangle. Since triangle FHB is an isosceles right angle triangle, it becomes a square rhombus. And the area of the rhombus is the square of FB, which is 8. And then we divide it by 2, because the actual area of the triangle is half the area of the rhombus. And we get the answer of 4 square centimeters, which is the same as using the first method. Now we know the area of both triangles. When we add them up, it will make up the area of the green shaded part, which is 18 plus 4 equals to 22 square centimeters. And that's the answer. And that gives us the same answer using the first method. Today, we have successfully solved this problem using 2 different methods and also learned something new. I hope it was useful to you. Bye!